Hello everyone, today I am going to do a complete walkthrough of my full stack POS system which I made with layered architecture. In this video I'll cover the project structure, execution flow of CRUD operations and place order, JPA mappings, annotations, exception handlings and validations that I used in this project. In layered architecture, we can see layers. Each layer has a specific responsibility and all of them only communicates with the layer below it. When we get top to bottom of these architecture layers, we can see controllers, service layer, repository layers, and then the data layer. To communicate in between these controller layer and service layer, we use DTOs to transfer data, and service layer and the repository layers, we use model mapper configuration class which has been we used a bean to convert these DTOs into entities, and we use entity classes for do database mappings in between repository layer and the data layer. Let me explain the full execution flow using save customer as an example. User fills the customer form, management form in the front end. Click the save customer button. It sends a HTTP POST request with JSON. When we click that service customer button, triggers this method. So as you see, when we get the inputs, we send an AJAX request with JSON to this URL. When these requests sent, it comes to the controller, customer controller. In this controller, we can see some annotations right here. So in the REST controller annotation, it tells the HTTP request automatically converts return values to the JSON, type JSON. And these required args constructor, it's from Lombok annotation. It generates a constructor for the dependency injections, and the request mapping, we put the URL here, so we can map the extract class, the extract controller that we want to communicate with to the front end, to the back end. In this cross origin annotation, the front end executes in a different port and the backend executes in a different ports. When we work with both of these ports, we can get a cross origin error for so to avoid this cross origin error, we use this annotation, and when we get the post method, because we used save customer as an example. In this method, we can see another annotation. It is the annotation which convert the incoming JSON body into a Java DTO. So this is the DTO I used for the customer. I already said that when we transfer data in between customer controller and the customer service layers, we used DTOs. So in this DTO, you can see getters for get data, setters for the set data. All are constructor to pass an object with all these attributes. So no constructor for the default constructor, and all the attributes that I want to pass data through an object. This is a validation that I used for the ID, and this is another validation for used for the strings like name, age, like that. So you can see the message that popped out for the when we input an incorrect input. In the customer controller, we get these the object, these data through an customer DTO object. We save this, we put this object into the save customer method in customer service layer. So when we go to the customer service layer, it's a interface because when we directly uses the customer service to the implementation, it triggers the tight coupling. When we change something in the control layer, it directly affects to the service layer. To avoid that, we use an interface to convert tight couplings into the loose coupling. So we use this implementation service implementation class to the implementation service method, save customer method is right here. So you can see still we get the parameters as DTO as the parameters. So we put these, convert these DTOs into the entity classes through this model mapper. In this model mapper, in this configuration class, we use bean object to return this to do this convert DTO into entity. So when we convert that DTO into entities, we pass that from the service layer to the repository layer. We triggers this save method in the repository customer repository. Through the customer repository, we can see we have extended this interface to JPA repository. So when we triggers that save method, it directly access this JPA repository interface. So I forgot to mention that the model mapper configuration class have two annotations. First one is configuration annotation. It says that this component should put in the Spring container. And this being annotation, we can create an object which not developer develop into a Spring bean. So after this repository layer, it directly goes to the database to save that data through the customer entity. We can see here the customer entity. In this customer entity, all the getters, setters, all are constructors, no are constructors, and especially the entity annotation. It is the annotation that says this is an entity class. So it can directly map to the database. And the table annotation, it says the table which creates in the database should have this name. And in the customer entity, we can see this ID annotation. It says this attribute is the primary key. And for the generated value entity, it says this attribute must be increased automatically. I mean, we just because it is an ID, we said from this generate this ID automatically. From this column annotation, we says this attribute should have this name to the column in the database. This says that can be null. And there's a mapping, one-to-many mapping from customer to orders, which says one customer can put many orders. So from this cascade type, I can put all here. So it means when we update or delete a customer, automatically should update, delete, or anything else to the orders. As example, we get a delete. When we delete a customer, automatically should delete all the recordings of it order records. And is this fetching? I used lazy because I don't want to get all the database operations when we call the parent. So I do put this in lazy. So here in the customer service implementation, we can see I have used exceptions right here, not in the save method, but in the update and the other methods. So I have created a global exception handler class to handle those exceptions. The method argument not valid method for handle validations like I said already, not blank, not null in DTOs. So when the null pointer exceptions, this is for the null pointer exceptions, and handle illegal argument exceptions. It handles every invalid arguments like wrong data types and all. This number format exception I have used to say that invalid data type. I mean, anyone can put a string into a number and like that. I also have done a thing in here. You can see every in order. Every item ID and unit price I have get integer and double. Quantity also integer, but in item I have get this in string, so it can trigger a number format exception, so I have used that also here. And definitely the customer not found, item not found, order not found. For the not found exceptions 404, then I have insufficient stock exception to get an information about that I have enough stock for the order to place. And I have used a generic exception method to handle any other exception like errors in server errors and them. So I have used some exception classes to these exception handlers. Customer not found exception right here, and insufficient stock exception, item not found exception class, order not found exception class, and for the now you can see we have described the flow of request and for the respond I have used this API response class to do that. When we take one data set from the database to the front end, we can use the flow as the data layer to the repository and the service layer and the at least the controllers. To the front end, so user can see error message or success message proper. So in this API response class, I have used generics to pass data in any data type. So I have used this status attribute to pass the status code like 404 not found, like and this string type message is to get a clear idea of the what is the problem or the if it is success user. From this message I have put a user friendly type message, and from these data attribute I can put some datas, real datas to show, but in the customer controller I have used it right here. For the status I have written 200, and for the message customer saved, and for the data of course I don't want to show them that the real data, so I kept it. Then HTTP status is created. It can be okay, bad request, and anything. So let's get to the order. In the order, uh, we can see the exact same the flow, but it's different in the logic. So I'll show you the implementation of the logics in this place order. So first of all, I have validated the ID, customer ID, if it is available or not. Like when we put an order, we should have a customer. If it is not saved a customer in that customer ID, it should throw a customer not found exception. When an item is not found, we should throw item not found exception. And I have already validated all the inputs that I want to place this order. So we have you do the validation of the cart. I mean, if the item ID is null or the quantity which I want to get is null, it triggers a illegal argument exception. After these validations, I have do the validating quantity and the unit price, because you can see in the item entity I have use them as strings in order item, so I have to convert them into the double and integers for the calculations. So I have converted the quantity into integer and the unit price into double right here. In need of a case, I have throw an exception. I have a number format exception right here. And if I had a problem in stocks, if not stocks available, I have do it right here. If the quantity of this item that I wanted is larger than the available quantity, it throws insufficient stock exception that I implement here. So finally, the placing order. So when I have created one entity for each one item, and all of these items I have added to a one cart and then the place order. So I have passed here order and item objects and unit price quantity right here, and all of them added to the order items. Order items here, you can see order items is an array which in item order item entity. This entity is for just one item. So all of these items finally saves inside an order, inside the order, which is the place that I use to save all the details in the database when clicked place order. Here I have calculated the reduction of the stocks. When I place an order, I should reduce the quantity of the item that placed the order. So right here, this is the quantity I want to get, and this is the available quantity. This is the new quantity that I should update in the stock item quantity column. So I have saved that, updated it in that in the item set quantity through the set quantity method. So finally, all of the stuff going to the final part, the place order. I have set all the single items into the order, which in right here called order entity, fetch mapped right here the customer and single item orders. So many to one with customer through customer ID. It means a customer can place many orders. The customer side is one and many side is to the order, and one to many with order items. One order can have many order items. So right here, we have set all the order items into the order entity and saved them through order repository to the database at once. So the reduction of the stock, saving of the all data of the place order is all saves in the database at once right here. So we can go to the controller. You can see the POS mapping for the place order with the API response. So let's go to the front end side, because I have already explained all the things, the execution flow, annotations, exception handlers, so the validations and all in the backend. So for the front end, I have already created customer, item, and place order HTML files with navigations, a simple form, and few buttons to save, update, delete, like things. So a table to show data to the users. Definitely, I use Bootstrap to do those things, and jQuery for the JS part. And uh, I have a style sheet to style those HTML for the body, and for the background colors I have used sea green and dark sky gray for with a linear gradient for the background of the body, and for the head light gray. Head means I have written heading like customer management. It's in color light gray. So background color is definitely dark straight gray. So for the navigations, background color sea green, and text align center. I have used navigation POS right here. For the form and for the buttons, for the save button hover, like that. And those are for the table, box shadows, border areas, the simple stuff for the table head, table body, and the JS file for the all front end functions. Save, update, delete, get all. In the get all, I have used right here. I have created the table body. You can see in the HTML, I only put the table head, but the table body is empty. So I have set it right here in get all customers. This method for the clear the imports, and for the buttons, and this is for the click when I click a row in the table, it automatically fill the fields, so I can easily update or delete. So let's get to a demo. Before the demo, let's talk about the application.properties file. Here's the place that we manage the database, create database, and all the things, connection to the database. Here's the driver, MySQL driver, and right here we can see I have created the database in this spot. If the database is exits, if don't create, and if not exits, it should be created. And the username, password, and pool size, maximum pool size. Here I have used JPA configurations with Hibernate. So here I have used create draw because it's easy for the development, and we can use here update, create, any of thing. It's easy when we have update if we already finished our development. So this is the application class that we executes this. So um, so this is my front end, and Uh, let's fill this. Updated successfully. Clicked. All filled. Let's say Dewmi, an update successfully updated, and let's something here to test. Delete so deleted. An item, it's 3,100 quantity. Okay, let's burger. Quantity sale. So I have already added one customer and two items. Let's place an order. You can select the customer by ID and the item. You can see automatically fill these fields, unit price, and the available quantity. Let's get 10 of these. Add to cart. You can remove it. So select the item, let's say 20, add to cart. If wants more from first item, let's get 10 to cart. Updates right here and place order. So in the database, you can see customers, right here, items, right here. You can see we put hundreds of all both items for the quantity, but now have 80 for each one because we ordered 20 pizzas and 20 burgers. Order table. You can see all these items have placed under one order ID. So item quantities has been reduced, so our place order successful. So this is the system I have made. So thank you for watching.